What's up, Formula Ed fans? Welcome back to the breakdown of Engineers Corner. I know I've been a little delayed. I caught something and haven't been feeling too well, so I've had to kind of take a little breather, but I'm back and looking forward to diving into these questions with you guys. So I'm diving into the question that covers the telemetry data that I had from a vehicle and of a vehicle on a track, and it's going through a turn. And I've asked the question of, is this a late, early, or mid corner apex? So the answer was a late apex. And the governing equation that I'm focusing on or indicating here, which I did cover in some of my content on Instagram, one of my kind of learning or read ahead slides, if you want to call it that, is the corner radius equation, and it is v squared over g lat, or the vehicle's velocity squared over its lateral acceleration. And this is a pretty interesting one to kind of understand, comprehend, and really understand what these terms actually mean. So let's kind of dive into it. So the first thing I try to indicate to people that are interested in becoming an engineer or are I guess doing this as a hobby, if you like to go to the track and run analysis on your vehicle and capture data, and there are governing equations associated with that performance. It's really good to understand the shapes that you would anticipate to see on the data. So now, let me caution with that. Not everything is going to be identical. So if you have this v square, I've correlated v squared to x squared. Um, that's not always going to be the case. It's not always going to be perfect. My goal is here is to emphasize that it's really good reference, and it's a good baseline to start from. So I'm not saying that it's going to be identical. What I'm saying is that it's a good baseline and a good idea to have this vision of what this might look like. Or you could just Google it, to be quite honest with you. It doesn't really require too much effort, but it's to go in there and make sure, hey, what am I expecting to kind of see here? So I'm expecting to see this parabolic shape, and I look over at my corner radius plot, and on the left-hand side of it, I don't really see a graceful kind of parabolic shape. I see this straight line drop. So I'm like, okay, well, that's a bit of a red flag there, because we see this larger value up at the top and then this massive abrupt drop. So that tells me that, okay, somebody's probably hit the apex a little late. That just gives me the indication of, okay, there might be a late apex here, because there's this massive abrupt drop in the middle. So that tells me that they're potentially going to be the slowest in the middle and then fast out, which is an indication of late apex. So just by the plot shape, right? I've see this, and I've already kind of indicated, this is interesting. So then the next element is the lateral G. So we go into the lateral Gs. So again, for late apex, you're typically going to be slowest in the middle and then fastest out. For an early apex, you're probably going to have a nice fast entry, but then a slow exit. And then for mid apex, you're going to have a pretty high average speed across it. And that trend should kind of tell you something there. But in terms of the lateral G's in this particular instance, you see this drop down to negative 1.31. So we're at 0 at one point, and then we go to negative 1.31. And then you see this kind of linear trend outward. So we see a decrease in lateral G, and it essentially makes more longitudinal grip available for acceleration out of the corner. That's what we're essentially seeing, right? But what's really important here to understand from all of this is that it's a balancing act behind the longitudinal forces and the lateral forces. So let's cover. So fast entry, slow exit is early apex. So if you come in really, really fast, that means that you're going to come in with a lot of kinetic energy, and you're either going to slow down or you're going to lose control. That the lateral forces are going to have their way with you. And then similarly, with the highest average speed, which would be the mid apex, you have the highest average speed, which indicates a nice balance between the longitudinal and lateral forces. And then lastly, for the late apex, you're slowest in the middle, right? And then you're fast out. So you've come in slower, but you have the ability to accelerate more quickly outward. so that those lateral forces aren't exactly consuming your vehicle as they would, say, with a fast entry or an early apex. Uh, and that's really the key element to understand in this particular assessment, and what you should be looking for when you look at this corner radius plot and then you look at the lateral G's. Now, I know other people have kind of taken speed into consideration and so on and so forth, and there's a lot of elements you can take in with this assessment, but nonetheless, that's what I was really trying to focus on, is to understand that balancing act, and how that's described. And I'm sorry, that balancing act between longitudinal and lateral forces, and how that is balanced and then described mathematically and then showing up on your telemetry plots. And that's what I wanted to indicate here. So I hope this was a good breakdown for you. And if you have questions, please fire them away in the comments below. I love to continue these discussions. And if you're interested in engineering or learning these things, and you have questions about the field or not sure, message me on Instagram, or reach out to me. I provided my email on Instagram. You can contact me there. But and if you don't mind, if you can share these videos, of course, like and subscribe. Helps me grow and eventually lead to making this my full-time passion and career. So definitely appreciate the following and the likes, and looking forward to doing this more with you all. Have a beautiful, I guess, morning, afternoon, or evening, wherever you are, and looking forward to chatting with you guys in the future. Take care.